Thank you. It's good to be here. So I decided, when we talk about organic chemicals, we are talking about a myriad of chemicals, as already was mentioned. We're talking from pharmaceuticals to things that come from our personal care products, our consumer products. And so we can't get away with it, and a lot of it really enhances our quality of life in terms of how we live every day. So I wanted to focus on the balance between using waste-based fertilizers. You've heard biosolids mentioned. That's one type of waste-based fertilizers, but there's others. And how that can impact soil health, human health, plant production, without forgetting overall environmental sustainability. We can always just say, you can't use that anymore. But then what do we do with the millions of tons per day of biosolids, as one example, that are created from our own waste that go to our wastewater treatment plants? So we have to be really balanced about it. And so when I'm teaching the different classes I teach at different levels, I try to highlight that. So that's what I want to stay with that theme. So we know that if we don't use them and apply them to land as a fertilizer, they're going to go to landfills. And so we're just creating time bombs all over the place. And I wanted to also focus on urban soils because in the production world, there tends to be a very, limited, we always say 1 to 3% of the top 15 centimeters might be an amendment because you're mixing it with soil. That's a really small amount. So you already have 100-fold dilution as soon as you apply it. But what you can start to observe in a lot of community gardens, or even in just people's personal urban gardens, what they call soil is entirely a waste-based matrix that they think is safe because they've purchased it from Walmart or Lowe's or Home Depot. They have no idea what's actually in that material. So I'm kind of going to focus a little bit on that, but some of the principles apply across the board. And when we're talking about hundreds and thousands of chemicals, I just am going to give a couple examples in this talk. So something that I've been working on for the last 12 to 15 years have been the perfluoroalkyl substances. Raise your hand if you're familiar with them at all. I was hoping to see more hands. Okay. So they end up being alkyl chain compounds that are highly fluorinated, which is different than some of the compounds you're familiar with, polyaromatic hydrocarbons, polychlorinated biphenyls. They all are rings with different constituents on them. So this compound class is, if you're wearing, almost everybody in here, I guarantee, is wearing a stain-resistant piece of clothing, because we love stain resistance. We love that we don't have to, we can keep our clothes a long time. Well, guaranteed, they contain these perfluoroalkyl substances. Aqueous film-forming foams. Your carpets, they're all treated with stain resistance. Your popcorn bags, until recently, were all coated with these compounds. All you have food service ware, they still contain these compounds. And the truth is, I think the European Union just posted, they've now posted there's 4,600 of them. The problem is there's growing concern in terms of their health effects and their resistance to microbial degradation. So a lot of the compounds can degrade a little bit, but they can degrade to a suite of compounds that are terminal end products. That's it. Microbes, we haven't seen them do anything more, and there it is. They also they tend to be mobile. We call them our PCBs for the next 40 years, but PCBs tend to accumulate in fat. These compounds accumulate, they bind to proteins, they're in our blood, our liver, our kidney, and they can accumulate, but they also are mobile. So they're kind of a trick contaminant class. And I'm going to talk more about those, but I did want to mention the other kind of big grouping in the trace organics that we might be concerned about are other compounds that are pretty persistent and might invoke other kinds of effects. And so I've listed antimicrobials, antifungals, antibiotics. They've already been mentioned. We don't know how low levels of these compounds in our soils, when they persist several months to several years, how that affects microbiome. Is it a significantly negative effect? I don't think we understand that. And so that's something I won't talk about as much, but I wanted to throw it out there. So here's just one example to just prove to you about these perfluorinated alkyl compounds. So on the left, you will see, I don't know, there's probably 30 different waste-derived fertilizers. Some have biosolids in them, some don't. All the top part, those first 10 bars where you see a lot of blue, those are actually composted waste that people use as a fertilizer. with food and compostable food products. That's what's going to be, the typical homeowner is going to be doing that. And it turns out that they're quite loaded with perfluoroalkyl substances. Another thing you see here, you see that whole list, that's just 17 of the terminal end products of these perfluoroalkyl substances. Different chain lengths, all perfluorinated. And then you see kind of in the middle there's not a lot of bars. Those are other types of waste-derived fertilizers. And although they won't have PFAS in them, they have other compounds that are of concern, but I'm not dealing with them today. And then the bottom half is a range of different biosolid-based fertilizers. Some are composted with other materials. Most of them are EQ or Class A, so they're supposed to be protective of pathogens, but we're not dealing with all these other compounds. And what you see on the right are actually, I'm showing you concentrations in pore water next to these materials as a function of the loading of that material. And you can see increasing concentrations of different compounds I've exemplified there. That red dotted line is the only current EPA health advisory out there, which is just focused on 2 of the 17 I have there, total at 70 parts per trillion. Not parts per billion, not parts per million, which is what we usually talk about with a lot of other compound classes. So this is putting a lot of pressure on the use of biosolids, because now we have these really low levels, and we are still very confused about the toxicology of these compounds. I think I had, yes, I was going to mention one thing about climate change, because I know that's going to that's going to keep coming up. So I wanted to say that on the climate change perspective, increased rain events means we have increased runoff, increased transport through tile drains. And unfortunately, all the best management practices that we use don't work very well because of the 80-20 principle. 20% of the highest flow events in a year delivers 80% of the chemicals, nutrients, metals, organics into the waterway. So just I had to put in that for the climate change proponents here that are really big on that. So the kinds of questions that I think are important to ask so that we can have research that leads to better regulations is, what are the dynamics between organics, but specifically the PFASs, soil type, amendment type? What things really are controlling the bioavailability or the leachability of these compounds? For different crops, is their ability to take up these compounds, because some of them are pretty mobile. Some of the ones that we don't have regulations yet that people are concerned about actually get taken up quite a bit in plants. But how is it different for different crops? Where is it going in the crop? How is it different depending on soil properties? You've heard that, at least a dozen times. How does the amendment affect things? And then what's the contribution of PFAS exposure via dermal contact in these community gardens and inhalation? That was already mentioned. I mean, community gardens are kind of like our kitchen. It's a place of social activity. And, so what's going on here and a lot of their garden, it's not like what you would think about a soil. It's a lot of amendment. And so what's happening in that? And then what's the long-term effect of chronic exposure of mixtures? Because we've already heard that. It's not about a single chemical. And so those are the kinds of questions that I would want to see answered. And I would think that funding in this area could help develop predictive models on fate, bioavailability, and effects, which will improve our risk assessment so that we're not overly conservative, which usually leads to another problem. So we really need to be balanced. We need, as already been mentioned, a framework of how do we deal with soil and human health in a functional framework that considers sustainability. You can't just ban everything. We have to have proper perspective, and requires a lot of different kinds of scientists, including human dimension, for communication and helping public understand what they should be concerned about, what they shouldn't. How does nutrition affect the real impacts of these contaminants when we ingest them? We've been dealing with them for a long time, so we're not all dead. So we need a better understanding of that. And then there's a lot of agencies, and most of them have already been mentioned, that can fund this kind of work. And of course, I didn't do terabyte billions or whatever, but yeah, the 5 to 10 million brackets. So thank you.